Hi, Dr. Romano. Looks like you're doing a little general chemistry today.
I'd like to go over a question on thermochemistry. That'll give you a good idea on a solid problem, and I'll show you some math tricks on how to go about solving it. There's always the whiners in the group who wonder if the numbers are going to be nice on the DAT. The numbers are going to be really nice. But nevertheless, you still have to know basic arithmetic, at least be able to hit a problem and be able to do an estimation. So this problem will give you good practice. What I have here, it says that when aluminum reacts with chlorine, aluminum chloride is formed. 1408 kilojoules of heat are given off. So right off the bat, we know it's an exothermic reaction. How much heat is released on reaction of 5 grams of aluminum? Now, the first thing you need to do is to write the equation out. So we're going to take aluminum plus chlorine, and it gives aluminum chloride. So I'm just going to, for a second, take these numbers away, and this is the way you would have started the problem off. Now, a student from the study group named Steve in Boston, he wrote to me and he had a great question, and he said, where would you really start when you're balancing an equation? There's really no one rule where to start balancing an equation. It's like doing a crossword puzzle. Personally, I don't waste my time on crossword puzzles, but if I did, I would probably suggest to do the longer words first, so you get more letters. But at any rate, I could give you a rule of thumb, though. When you balance an equation, try to balance the metal first. So if we did that, and we balance the metal first, I see there's one aluminum here and one aluminum here. So that doesn't really help me much in this case. The aluminum's the metal is balanced. I look here and I see there's 3 chlorines here and 2 here. So what I want to do is to say, what's a common denominator between a 3 and a 2? That's a 6. So if I put a 2 in front of here and a 3 in front of here, this gives me 6 chlorines here, 6 chlorines here, and then all I needed to do was to put a 2 and balance the aluminum. So you should be able to write a reaction and be able to balance it. Now, all I'm going to do is dimensional analysis. I'm going to take 5 grams of aluminum and convert it into moles as usual. 1 mole of aluminum is 27 grams. Grams cancel out. 2 moles of aluminum react to form 2 moles of aluminum chloride. So notice the moles of aluminum cancels. And finally, the whole reaction is minus 1408 kilojoules, and that's for 2 moles of aluminum chloride. So what I did is cross that out, and I got my answer in kilojoules. So it's going to be 5 times 2 times minus 1408 over 27 times 2 times 2. And as you guys can see, the 2's would cancel out. So I'm left with 5 times minus 1408. Now, 27 times 2 is 54. Oh, bullshit, 54. Call it 50. So I'm going to call it 50 to make it into a nice number. But notice this number should be 54, though. But I called it 50. So I'm dividing by a smaller number. So that means that whatever I get as an answer, I'm going to be a tad bit on the high side. So keep that in mind. Now, a nice little trick, 5 over 50 is 1/10. So basically, all I'm going to do is to take 1/10 of minus 1408, which comes out to be about minus 140. And we know we're a little bit on the high side. So therefore, what we're going to do, when I say high side, don't look at the negative. Just look at the absolute value. So instead of being minus 140, again, don't look at the negative. The negative just means that he was given off. So that means that the answer would be probably around 132, 130, in that ballpark. And the actual answer was negative 130. But you needed to get a feel for when you did an estimation like this, you would be able to feel comfortable on the answer of 140. But if you divided it by 54, it wouldn't be quite 140. It would be less than 140. I hope this gives you a really good understanding of how to estimate a number. You got to be able to crunch a number like this, because on the DAT, you're very well going to see a question where you got to make a little bit of estimation. All right, I hope this helps on a really solid thermal question. If you got this right, you did good, and I'll see you in study group again.
Okay, Dr. Romano, would you like a donut or some hot chocolate?
I'm good. Good day to you. Bye-bye.
Good day to you, sir. Wow, it never stops. Goodbye.